right, maybe we'll get started. So hello and welcome everyone. Thank you so much for joining us as we launch our multidisciplinary research project on mobility device damage during air travel. My name is Allison, and I'm one of the research analysts on the engineering health team at the Kite Research Institute. Presenting with me today is Dr. Tilak Duda, the principal investigator, Hannah Dudney, and Ziad Ghulam, who are both research analysts on the team. And Tilak, would you like to say hi?
Hi, everybody. I'm really excited to have everyone joining us today. It's great to see so many familiar faces.
Hi, everyone. My name is Hannah, and I'm a research associate here at Kite Research Institute and a PhD student at the University of Toronto. Nice to meet you all.
Hi, everyone. I'm Ziad Ghulam. I'm a research analyst in the engineering health team. Nice to see you all.
We also have some additional members working on this research project on the team who aren't presenting today, including Victoria, Simone, and Kim. So before we begin, I'd like to start with some housekeeping notes and a land acknowledgement. We will have time for questions at the end, and if you like, you may put your questions in the chat box during the presentation, but we ask that you be mindful of your use of the chat box as it can cause interruptions for anyone using a screen reader while attending this meeting. We have an ASL interpreter available. To turn on ASL, you can locate the globe icon at the bottom of the screen, click on that, and then turn on American Sign Language. The research team would like to acknowledge that the land on which this meeting is hosted is the traditional sacred territory of many First Nations civilizations, including the Mississauga of the Credit, Anishinaabeg, Three Fires Confederacy Peoples, the Haudenosaunee Six Nations Confederacy Peoples, and the ancient Wendat peoples. We are sharing a presentation today, and on our title slide, we have some images of mobility devices, including a motorized wheelchair, a scooter, a manual wheelchair, and a walker. Our presentation is titled Preventing Damage to Mobility Devices During Air Travel. I'll now pass it to Dr. Tilak Duda to introduce our project.
Yeah, so the problem, of course, I think everyone here is probably well aware of. Mobility devices, wheelchairs specifically, seem to be getting damaged far too often during air travel. And the person that's really brought this into the spotlight has been Maayan Ziv. And she posted, I think this was the first time it really came to my attention anyways, was through her post on Twitter in 2022, where she described where she showed a picture of her broken wheelchair after a flight. And it really set off a lot of attention with the media and with the government. And it's probably the reason that we're doing this project now as a result of this. So if you go to the next slide, please. And the good news, I guess, is that there is a long-term solution, as we've already heard. This Air for All wheelchair. There are a number of people working on this idea of having people take their wheelchairs on board into the passenger compartment of an aircraft, rather than have to be separated from the wheelchair and have to have the wheelchair go into the cargo area, where, you know, that's the part of the process where the wheelchairs are getting damaged, getting them into or out of the cargo areas or during the flight itself. So the good news is there is long-term solutions and in the works. However, it will take some time. We did see, I think some, I think we saw a post a couple of days ago describing this from Christopher. In fact, if that was his LinkedIn post, I believe that Allison shared with us, to say that the FAA had made a move recently to say that they're looking into this further, which is very exciting. However, there is a need for something in the shorter term, so this is where we come in. Next slide, please. Yeah. So Accessibility Standards Canada, in conjunction with the Canadian Transportation Agency and IATA, the International Air Transport Association. Sorry, on this slide, I'm showing four logos, the three from those from Accessibility Standards Canada, Canadian Transportation Agency, and IATA, as well as our team's logo. Accessibility Standards Canada reached out to our team to see if we could help address this problem, to look at it. And together we came up with a proposal that we'll share with you here. They funded us starting in June of 2024, and it will be a 4-year project. And so we're excited to have you all, and we're asking you all to join us on this project. Yeah, if we go to the next slide, we can describe. So we have 4 other logos on this slide to underscore that there's been a lot of great work that we will be building on top of, and people that we will be working with as a part of this. We've already made some great connections for people that are working in this area. The 4 logos are from the NRC. So Shelley Roberts and her team has done some previous work, and she just described some of the work that she's doing now with the job aid. We'll be working closely with them. Muscular Dystrophy Canada just completed a survey of nearly 1,000 mobility device users, understanding their challenges with air travel. Motion is a company that supplies wheelchairs and mobility devices and has to deal with all the damage that occurs, and they know this problem really well. And Access Now is Maya and Ziv's company, and we'll be their partner on this project as well. Next slide, please. So there's really 2 big parts to this project. So the first part is understanding the problem, and the second part is developing and testing solutions. So on screen, I've represented these in 2 purple boxes, and then within the purple boxes are smaller blue boxes that represent the sub-projects for each of those 2 parts. So for the first part, understanding the problem, we will be understanding the problem using a number of sub-projects, including surveying travelers, surveying people who work at airports or for airlines, doing interviews with those people, shadowing the people that handle these devices, doing an environmental scan to find journal articles or standards or guidelines that airlines, airports, anyone out there is using to try to work with mobility devices, try to understand what's everything that's out there that we should be building on. And the most exciting part for me is the use of data loggers, sensors, and Ziad is going to talk more about that a little later. But the basic idea is we will take sensors, we will recruit people with wheelchairs that are flying to attach a data logger to their wheelchair while they're flying so that we can see what's really happening. Where is this damage likely occurring? Is it during the flight? Is it during loading, unloading? We're going to find out quite a bit, we think. From what we learn in that first part, we will apply in the second part and we'll try to develop and test some different solutions. One that we have committed to working on for the Canadian Transportation Agency is to develop a guideline on how these devices should be secured when they get into the cargo area. So that's something Ziad will talk about a little bit more as well. But the basic idea is we don't know what all of the solutions that we will need are going to look like. We're based on what we learn, we're going to develop appropriate solutions to try to address the problems that we come up with. And then we may test those solutions using those data loggers to see if we see a difference. So that's a quick overview. The other members of our team are going to give you more detail on each of these sub-projects. So I'll turn it over to Hannah. Thanks.
Thanks, Tilak. Okay, so there is a clear research need here that we need to further explore the problem. As Tilak mentioned, mobility devices are still getting damaged. It's really important to better understand what's happening from both perspectives. There's a lack of research that comprehensively examines mobility device damage and loss during air travel. So our research really wants to look at, for example, securement methods, loading and unloading, employee training, workplace environment, such as communication in the workplace, and more, just to better understand the current state of mobility device handling. We also really want to understand the inner workings of mobility device handling process, including what is working and what isn't working. So the image on this slide showcases a power wheelchair tightly wrapped in plastic wrap and tape that reads fragile. And this is from a CBC News article. For the two main objectives of our project, Talk touched on these. We really want to investigate and understand numerous potential causes of mobility device damage and loss. And this could include discovering new causes that we just may not be aware of yet. Our second objective is to create a set of resources or recommendations to reduce the risk of damage and loss of mobility devices during air travel. And there'll be many deliverables that come out of this project. And all the deliverables will be guided by what we discover during the early phases of our project from travelers with lived experience, as well as employees that work for airlines, airports, and third-party contracting companies. So these deliverables will offer guidelines and recommendations, as I mentioned, for securement, for example, and different aspects of handling. These guidelines and recommendations could include training materials, training content, improved communication mechanisms, and technical guides. Ultimately, we really want to ensure that these deliverables have meaning and value and resonate with both the needs of travelers with disabilities who use mobility devices and airport, airline, and third-party employees. So this image here shows a timeline of the 4-year project. As Talak mentioned, starts in 2024, finishes in 2028. So we have some time to work with here to really delve into this, which is exciting. Starting on the left, more recently, we began to work on our first phase, which is the environmental scan and survey development. So next, we'll continue on to interviews and shadowing in airports, and then we'll look at mobility device data logging. Finally, we'll develop and test any of the solutions and interventions that we come up with from this. Next, I'll go into some more details about the specific sub-projects, but this is just to give you a sense of timeline-wise how things will be occurring. So these sub-projects here are just a list on this slide, and then I will go into more detail, as will Ziad. So as Talak mentioned, there's going to be an environmental scan. This includes academic and non-academic sources. We have 2 surveys, which will include interviews with travelers who use mobility devices that have been damaged or lost, and employees who are involved in handling or managing mobility devices. There'll also be a simulator testing, as well as developing interventions and the data logging, of course. To expand on our first sub-project, the environmental scan includes academic literature, and by that we mean peer-reviewed journal articles, also conference proceedings, and we really want to gain a better sense of past research and what we already know, and see where there are some gaps in our knowledge. This importantly includes ensuring we don't replicate what other community and research organizations have already done. So for example, the international survey by Muscular Dystrophy Canada really helped inform one of our first surveys. And we also want to include news articles, industry magazines, blog post guidelines, training materials, and social media so that we can better understand lived experiences and the stories that people have already been sharing with us for years. Pardon me. So next, we're in the process of developing 2 surveys with corresponding interviews. And this will be where we can maybe get some help from all of you, but I'll explain that in a moment. So the first will be the surveys and interviews with travelers who use mobility devices. Specifically, people who complete the survey will be people who have traveled with a mobility device in or out of a Canadian airport in the last 5 years and have experienced damage or loss. The timeline of this survey is approximately December 2024 to 2025. And then it will be available in English and French. And we really want to determine what factors may be impacting the likelihood and severity of mobility device damage. And this will lead into some interviews with these folks and hopefully to gain a better understanding of the factors. Next, of course, we will also have a survey and interviews with employees who are involved in the handling or management of mobility devices. This includes people who work for Canadian Airlines, airports, and as third-party contractors for Canadian Airlines or airports. The timeline is approximately January 2025 to January 2026, and also will be available in English and French. We really here want to identify the factors that may impact employees' ability to handle mobility devices properly. As we know, I can probably speak for everyone when I say people don't want to make these mistakes. It'll take a lot of teamwork to work together to figure out and see things from both perspectives in this case. So it could include workplace stress that we'll look at, other constraints in the workplace, such as physical load, training received, and lots of different factors. Importantly, for both of the surveys, as I mentioned, we would love to be able to identify some people in attendance today or folks that you may know who may be willing to help review our survey drafts and help design these surveys so that we're not missing anything. And that's just one step in addition to the diverse team that we have working on these surveys already. I will now pass it off to Ziad to talk a little bit about data collection with our data loggers.
Thanks, Hannah. So we're recruiting individuals who use mobility devices and have an upcoming flight to participate in a study. We're looking for people who would allow us to attach a sensor to their mobility device during air travel to help us better understand what is happening to these mobility devices throughout the entire travel journey. The data logger we attach will track events such as if the device is dropped, flipped on its side, or back during loading or unloading, how much the device would move during takeoff and landing, and how it is affected by turbulence. The data loggers are powered by AA batteries and will be securely fastened to the mobility device with zip ties. They're designed to be lightweight, compact, and discreet. On the right-hand side of the slide, we have a picture of the data logger, which is comprised of a microcontroller and an accelerometer. And it's enclosed in a 3D printed black enclosure, as pictured in the bottom. To our knowledge, this part of the study hasn't been done before. It will give us objective information about what is happening to these mobility devices and how they're handled throughout the entire journey, from check-in to boarding, during the flights, and through to the final destination. Next slide. We've had an opportunity to pilot test this data logger with one of our team members, who is a wheelchair user. She flew from Toronto to UK, and a data logger was attached to her wheelchair throughout the entire journey. This slide shows the type of data captured from that very data logger, and I'll break down what's happening at each phase. During wheelchair loading, we see some sharp spikes, likely from handling impacts. At takeoff, we detect forward, sideways, and downward accelerations. This is typical as the plane ascends. Once in the air, the data flattens out, reflecting smooth in-flight conditions. The minor fluctuations that we observe could suggest turbulence or slight movements in the cargo holds. As the plane lands, the graph shows stronger forward and downward accelerations as the aircraft decelerates and touches down. Finally, during wheelchair unloading, we see some sharp spikes similar to the loading phase, indicating movement or impact during handling. So what's the key takeaway here? Well, what we learned from this data is during the flights, there isn't too much activity happening. It's leading us to believe that the damage is not occurring during the flights, but it is probably occurring during the loading and unloading phases. The data that we collect from these data loggers will not only allow us to identify at what parts of the travel journey the mobility devices are likely being damaged, but we can also use the data to drive a simulator at the KITE Research Institutes. KITE Simulator Lab allows us to recreate real-life movements and conditions that mobility devices experience during air travel. We can use this simulator to pinpoint which parts of the journey pose the highest risk to mobility devices. This will help us identify and validate exactly when and where the handling issues arise. Next slide. By doing this, we would want to come up with some guidelines on how different mobility devices should be strapped and secured on aircraft. So speaking of strapping and securements, currently ratchet straps are widely used to strap down mobility devices, as discussed in the NRC reports on safe securement and containment of mobility aids in the cargo compartments. Ratchet straps tend to be over-tightened, and depending on how these straps are applied, it might result in unequal distribution of tension across contact points. With consistent vibrations during the flights, portions of the strap length will be slack, which would allow the mobility device to slide during transits, thereby increasing the risk of damage. And this ratchet strap is seen to the left of the slide. To the right of the slide, we have an alternative solution, which could replace these straps with an automatic or semi-automatic locking retractor strap, which could potentially cause less damage as they self-tighten and lock. So this is a real-life example where the KITE Simulator Lab could be used to create test cases and scenarios to evaluate the effectiveness of this alternative solution or other alternative solutions that we might come across during our study. I'll pass it on to Alison now.
Thank you, Ziad. So as you can see, there's a lot of exciting research that's going to be taking place, and there are many ways in which we need your help and support. Our survey for travelers has been submitted to our Research Ethics Board for approval, and we're hoping to start collecting data in December of this year. We are currently preparing our survey for aviation employees. And so we are currently looking for people with lived experience or work experience who can offer feedback on these surveys to help ensure that we're asking the right questions. We are also looking to collect more pilot and preliminary data with the data loggers to test in our simulator. And we would also love to connect with people who could help us facilitate shadowing and observation opportunities at airports, and maybe share existing training materials with us. It'll give us a better idea of the training that is currently happening, what is working, and where some gaps may be. And on the next. So if you're here today, I know it's because you are interested in this research and you're interested in fixing this problem. So we will continue to keep you updated on our research. I promise we don't send that many emails. We only email when we have a meaningful update about our research or when we're putting out a call for participants. So there'll be opportunities for the surveys, interviews, that travel data, or to join an advisory committee. We are hoping to put together some committees of people who can really help inform this research, as we move through the next 4 years. And please spread the word. I know you guys have vast networks. If there are people you think who could help us, who are interested in participating in any capacity, please share this with them. On the next slide. This is very much a collaborative research opportunity. This is very much a problem that can't be solved by one group alone. It's really going to take all of us coming together to figure out the best way to prevent mobility device damage during air travel in the future. So please stay in touch with us. On this slide, we have my email address, allison.whiting@uhn.ca. We also have our phone number, website, Instagram account, and Facebook. And this information will be copied into the chat for easy access. Also, if you're attending this meeting today, you probably have my email, so please don't hesitate to get in touch with us. And looks like we're finishing right on time.